Moderator 2 dengar tak? Hello? Hello?
Bila ni dah
Aku jadi dulu jap. Sekejap. Aku dulu jap. So aku nak cakap dengan ni. Okay. Speaker, boleh ke saya nak minta speaker akan sediakan satu hint ke apa-apa, so kami daripada moderator boleh tahu bila speaker dah habis bercakap. Nak start live terus. Okay. Start Okay. Video
Hi, I am Faruza Amira.
Hi, I'm Gita.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Sakinah Si Ahmad.
Hi, I'm Khalija Jassi.
Hi, Assalamualaikum. I am Nur Intan Raihana Ruhayim.
Hello everyone, I am Nur Zarin Zulkarnain.
Assalamualaikum and hi, I am Hamira Hagia Abdurrahman.
Hi, my name is Farizana binti Hamzah.
Hi, my name is Nurul Akila.
I am currently a data scientist at ST Microelectronics and Chief Operating Officer at Ever AI Technologies.
I'm also the founder of startup Jenga.
Currently, I'm Associate Professor in the Department of Intelligent Computing and Analytics, UTM.
I'm also a statistician at DOSM.
I am currently a senior lecturer at the School of Computer Sciences, University Science Malaysia.
Currently, I am a senior lecturer at the Faculty of Information and Communication Technology, University Technical Malaysia Melaka.
I'm also a senior lecturer at the Faculty of Industrial Management, University Malaysia Pahang.
And currently a second year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Currently a final year student of Bachelor degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Women in AI is awesome,
Engaging,
Remarkable,
Passionate and dedicated.
And a great platform for building friendships.
so let's join Women in AI Malaysia Summit.
Summit.
Assalamualaikum. Here at UTEM for this Malaysia Summit. For this Why Malaysia Summit. So, my name is Mahira, and here is my partner, Imran. So, we will be your moderators for this session. So, how are you today, Imran? Can you brief me a little bit about today's session?
First of all, I would like to thank you for having me here, and thank you for asking, Mahira. Today, I feel in the pink. I'm also a little bit excited because this is the first time I can moderate the show. Now, before we go further on, I would like to ask the audience, people in the chat, how are you doing in this fine weather we are having today? I want to ask personally, people in the chat, how are you doing in this fine weather today? Great. Blooming and great from Dr. Shahira. Alhamdulillah, aren't we all? All right. Now, before we go any further, let's talk about the objective today. It is announced that there will be a Y talk, and then later we will have a Y masterclass in the evening, around 2 in the evening. This is also our soft launch for our next event for Y Summit 2.0.UTEM 2024. Now, Mahira, can you explain a little bit about what is this Y talk?
Definitely. Now, what is this Y? So, Y is a short form for Women in Artificial Intelligence. It is a non-profit do tank working towards gender-inclusive AI that benefit global society. Their mission is to increase female representation and participation in AI. Now, before we introduce our speaker, I would like to give our participant a link register to get e-certificate for joining our event. So, in this talk, Dr. Shahira Lebai Lutfi will delve into the importance of integrating cultural models into effective computing to create culturally responsive AI systems. Before we start, let me introduce a little bit about our speaker, Dr. Shahira. So, Dr. Shahira Lebai Lutfi earned her DEA and PhD degrees with distinction cum laude from the Speech Technology and Automated Learning Group at the University Politécnica de Madrid, Spain in 2013. She also has a master in software engineering from University Malaya and BSc Hons from University of Bolton, UK. I'm honored to invite Dr. Shahira to our talk. Dr. Shahira, the floor is yours.
Okay, thank you very much for inviting me. Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Shahira from the School of Computer Sciences, University of Science Malaysia. So first of all, I would like to say Jazakallah khairan to all the organizers for coming up with such a wonderful event, Women in AI. Okay, and a special thank also to Dr. Nur Intan Raihana from Computer Science, who has specifically approached me to do this talk. Okay, all right. So without further ado, can everybody see my screen here? Can I get a thumbs up at the chat button? Okay, I guess all of you can see the screen. All right, great. So today's talk is what we're going to do is we're going to delve into culture computing. This is important to build, or at least towards building. This is what we're attempting to do, to build culturally responsive systems in a multicultural world. And before that, I think with a very generous introduction by the moderator, I would like to add on. Okay, I'm also an associate researcher in speech technology and machine learning group at SIT Universidad Politécnica de Madrid, which is my alma mater. And I am also holding the post as a deputy director of IMCC since 2019. IMCC is our International Mobility and Collaboration Center. And for anyone who's interested with this talk later, you can also want to know more things or want to comment or want to share. You can email me at shahira@usm.my. And you can also find my website, shahira.com here if you're interested with some of the work that I've been doing with my team. Okay, thank you. Now, let's start. Well, it's very simple. It's going to be a very simple talk. And in fact, I hope that it's going to be a two-way event, okay, where I will ask sometimes I will ask you a question and I expect to see you to type, and the moderator probably could read it for us, to make sure that, that people are actually understanding what I'm saying. So the two messages that I promise that you will take home towards the end of this talk is that you would be able to understand the function of affect, okay, which is another word for emotion in AI systems. And also second, you would be able to understand the function of culture in AI system. Okay, and you can see here, everybody know that this is a zebra, kuda belang, right? So the zebra is also a good analogy. Zebra has actually white and black stripes or black and white stripe. What do you think? Can you type it in? What do you think about, what do you believe about the stripes of the zebra? Do you think it has white with black stripes or black with white stripes? Can you just type it in, and maybe moderator, you can read out to me, because it's not easy to switch screen. Maybe also in Facebook. Okay. Anyone? Let's see what people have got to say. Okay. Some of you may think that this is the zebra has white with black stripes, and some of you may think that the zebra has black with white stripes. No, vice versa. The actual thing is we never know, right? It depends on how you see it. It depends on your perception, so this is a very good analogy for culture actually. People from different culture have different perception when it comes to emotions as well. And it's also a very good analogy for pattern recognition, because that's how we combine emotion, culture, and AI. Okay, it's all about reading the patterns and turning the patterns into machine readable form, although it comes from social sciences, right? So different clusters of zebra has similar patterns of the stripes, but not one individual zebra has the same stripe as another. Okay, it's just like our thumb reading, right? Not one person has the same pattern of the thumb, okay, the thumbprint, as another person. So it's a very good analogy for culture. It's a very good analogy for pattern recognition as well. So with that, I'll move on to introduce what the industry is and the growth for a while. First, I would like you to actually watch this video. I hope you can hear it, okay? But if you can't hear it, don't worry. What I would like you to do is to look at the emotions of the host, of the expression, of the facial expression and gesture of the host, and also of the person that that is invited, okay, of the guest. All right, so let's start. And maybe you can type out what do you think the guest, later you will see the guest feel. Okay, let's start.
Need for the industry and the growth of music online. Well, Guy Cuny is the editor of the technology website News Wireless. Hello, good morning to you.
Good morning.
Were you surprised by this verdict today?
I'm very surprised to see this verdict to come on me, because I was not expecting that. When I came, they told me something else, and I'm coming. You got an idea of that, so it's a big surprise anyway.
A big surprise.
Exactly.
Yes, yeah. With regards to the cost that's involved, do you think now more people will be downloading online?
Actually, if you can go everywhere, you're gonna see a lot of people downloading to the internet and the website everything they want. But I think it's much better for the development and to improve people what they want and to get on the easy way and so fast everything they.
Okay, I'm going to stop here. So what do you think that this person, Guy Cuny, what do you think his reaction was when he was introduced just now? Anyone? Maybe you can type it. Maybe you can put some comment, what do you think that the reaction of the person was earlier on? Maybe there's some lag. So I'm not sure. Moderator, ada lag ke? Okay, Afiq Daniel says shocked. He was unexpected. So there's comments coming in. He was unexpected. All right. That is true. Okay, that is really very true. He felt shocked. Now, the story behind this is that, okay, I'm going to just show how he actually reacted, the frame here. It's still funny, no matter how many times I watch this video over and over again. Now, the story is that Guy Cuny is a driver. So he went to this media company, okay, for an interview as a driver. But because his name, he has a similar name, he's exactly same name, not really similar, as a very big digital media CEO company, they thought he was the CEO of this digital media company, and they put him in the limelight. They switch a person. So he did not expect to be there. So this is a very big blowout, right? But what you see here is that, well, it was a mistake. Yes, it's correct. It's a mistake. So what you see here is that he was shocked, but after that, he did not try to get up and run away. He was trying to adapt with the situation. And the host, who have actually realized that this guy was shocked, something is wrong, ada benda tak betul dekat sini. Okay, but the host also, because it was already on air, they were going on with the interview. So both of them are trying to adapt to each other, trying to adapt to the situation. So that is the underlying, that is actually the underlying reason, underlying objective of effective computing. It's all about trying to bring emotion into science by the science of emotion. This is what I like to say. Okay, so effective computing is really an area of study where we sense, interpret, and process human affect. Another word for emotion, lah. Okay, for a better adaptive. So that's the keyword: adaptive, more emotionally, and in a way, culturally sensitive interfaces or systems. Okay, the reason is to have a smoother and more natural interaction between human and computers. And this is mainly to mitigate frustrations, right? It started mainly to mitigate frustration. That is where effective computing started. But now it has already broadened, the functions are more. But that is how we started. So this is actually a multidisciplinary world. in order to work in effective computing, you need to have social scientists, you need to have statisticians, we need to work with technical people, we need to work with computer scientists, data scientists, we need to work with psychologists, because all these social science elements are the ones that we try to take and try to change, all these features into some kind of machine readable form. Okay, so a lot of people, they will tell us, don't judge emotionally, don't be clouded with emotion if you have some decision to make. But this might not necessarily be correct. Okay, when they say don't be emotional, meaning it usually a negative, it brings some kind of negative meaning, right? But we need emotion to evaluate matters, people, and situation. Okay, otherwise we are considered as autistic, right? For example, we have sentiment analysis. This is one part of natural language processing, one part of natural NLP, right? So we are starting to look at sentiments of people about what they think about our products, about our service, and this is also scientific finding. So we do need emotion for decision making, right? It's all about bringing emotion into science by the science of emotion again. Okay, so this is the loop where you can see the loop of affective loop. Very simply, okay, we are working with, we need to recognize the emotion. So we need to recognize emotion at hand in that situation. This we can use single or multi cues. The cues can be facial, speech. Later I'll be explaining about that. All right. And then once we have recognized this or detected this emotion, we are moving into the adaptation phase. We're trying to adapt with the emotion, or in another word, we try to match the recognized emotion with the suitable kind of response. So this can also be rule-based, okay? And then the response, how we train the machine to react or express with the appropriate emotions towards what has been recognized. Okay, so simply say the loop is a process that translates emotion, cultural elements, or features. Okay, technically we call it features into machine readable form. Now this is a sample interaction that you can see. It's also work done by my student. All right, and you can see. I think I've added, well, maybe not in this paper, but in this slide, but I've added the publication. Okay, the findings in the publication in my website. If you're interested, you can see that. This is a synthetic tutoring agent. Synthetic meaning it's just an agent, right? It's a computerized agent. What we tried to do is we wanted this agent to try to detect students' emotion while they are engaged in a quiz or in a test or online learning. So the camera, for example, would detect whether the student, we have senses, right? We have eyes, we have ears, we have nose. So when we see people, we will know, and then it goes to our brain, and then it tries to interpret. Or when we hear something, or when we try to interpret people's speech, or when we smell something, also when we touch something, right? So these are sensors. But for the computers, their eyes are the camera, right? So they use camera to, for example, to detect whether the student is feeling stressful. Okay, it's trying to recognize. This is the detection phase. And then once it has that recognized, for example, student is actually stressed, it tries to adapt. It tries to find a matching response. And before it can find a matching response, it needs to adapt. Okay, we need to recognize using deep learning, and then we try to adapt using some rule-based coding. And what it tries to do later is to try to find a matching response. So the response in this case can be to change. Okay, the student is detected as stressed, and so the response should be to change to less complex question to reduce stress. Now, if the student is detected to be bored, then maybe you need to change to a more challenging question, a more complex question. The same thing if the student, similarly, if the student is detected to be in flow, that means they are concentrating, they're in flow, that means don't change anything, just go on as usual. So this is how it works, a very simple example. All right, but how do we do it? Now we're going to move on to the next section of how do we do it. There are several ways, okay, several cues, we call it. Okay, the cues are actually, it can be by voice. Try to recognize emotion by voice. You know, when we, as human interaction, we could recognize people just by voice. You know, if they're sounding stressful, they're sounding, if this person is sounds angry or merajuk or any other kind of subtle emotion, correct? So by voice, so we can actually detect vocal emotion by gesture, the movement, expression, okay, gesture. By text, this is very, very popular nowadays, okay, since 5-6 years ago, since 10 years back, a decade ago, since social media is very popular. So a lot of textual information, sentiment analysis. Gait is the way people walk, all right. Interestingly, for the Southeast Asian, especially for Indonesians, there has been research findings that shows that when they walk, they like to drag their feet. Indonesians, Vietnamese, they like to drag their feet. And German, when they walk, they lift their feet very high, okay? And gesture, when they're Germans, you know, they like to stand like this with their hands like this, folded. All right, when with Japanese, they like to stand with their hand down, okay? So these are, you know, easily if you use this, you can do something like nation recognition or nationality recognition, for example. But the best tool for recognition is still the face, if you ask me, okay? The best tool are still the face. There are some other modalities, physiological modality, for example, galvanic skin reaction, we call it GSR, EEG, okay, EEG for the heart rate, and also fMRI, functional MRI, and a thermal-based systems to detect facial or bodily temperature, to tell the emotion, how to tell the emotion being expressed without depending on self-report, okay? But physiological detection can also be a little bit difficult because it's considered as, you know, busting into people's privacy. So sometimes it's not appreciated. All right, these are some of the selected works from me and my colleagues, and sometimes, you know, from my colleagues that I find interesting. One example is the empathetic tutor that I've done, I think, back in 2016 with one of my master students. What we did was we took like 3 different virtual tutors with 3 different races. Okay, so they have Malay tutor. These are also synthetic tutor. Okay, or virtual tutor. So there are 3 virtual tutors, static tutors. They cannot. It was very simple. They cannot. These tutors, they cannot express in different ways except for in text. So that the facial expression will be the same, the gesture will be the same, but their face looks different. I mean, we have Malay tutor, we have Chinese tutor, and we have Indian tutor. So we have design tutor that represents the 3 biggest race in Malaysia. What we found out is, interestingly, students, they have certain preference. So this is what we call similarity effect. So the Malay students are found to significantly prefer Malay-looking synthetic tutor. Okay, I think we made him look like one of the actors. All of them look like one of these actors. Okay, and Chinese student preferred the Chinese tutor. But the tutor performance are all the same. But we couldn't conclude for Indians because there are not too many Indian data in here. Okay, so if you want to read about it, you can go to my publication site. Okay, this is another example. Please listen to this. This is actually a work that I've long time ago collaborated with Dr. Narayanan. Okay, 2005. Can you listen to this clip? This is with permission from him. Listen to this clip. This is a real clip taken from a call center. Okay, I hope that you can hear it.
Delayed bag. Yes. Peoria. Peoria. No. Peoria. PIA. No. Can I talk to a person?
At the end of the day, this lady say, no, can I talk to a person? and you can see the energy going up, and you can see also the pitch. Now, using voice modality, usually we look at energy, we look at pitch, we also look at duration, okay, and some salient words. But the most important thing is how some utterance is being expressed rather than what is being expressed. So rather than looking at the words, what is the meaning, we are looking at how some expression being expressed. So in here, this is a frustrated caller who have been talking to system. Remember sometime when we call Celcom or when we call DG, or when we call, nowadays we cannot call Asia, but let's say, imagine you're calling the airline companies, you're put sometimes with the system, and sometimes it doesn't understand and you get angry. So in this project, the idea is very simple. If the person or the caller is detected to be angry or started to get frustrated, then switch him or her to a human representative instead of forcing the person to talk to a system. That is to mitigate the frustration. This was one of the early work. Okay, now it has been more advanced. This is another work that we work in when I was in my Spanish lab in UPMA Madrid. Okay, on a text-to-speech system. This is under a EU project, Simple for All, where we try to embed speaking style, or what we call speaking style transplantation in speech synthesis. Simply, what we did was to put someone voices into another person's emotion. So this is because of data. There's a dearth of data is not enough for us to train the system. So what we did was we took small portion of data of one person, and we train the emotion of another person. So the emotion is there, it's the same emotion, but the voices can change. So for example, I have sort of like a Malay emotion, right? But then when they used a Spanish voice on my Malay emotion, it doesn't really match because they are more expressive. All right, I am expressing myself, but they are even Spanish. People from the Mediterranean area, they're very, very expressive. For example, Italian, when they speak, they're speaking normal, but you think that they are fighting with each other. That is because you're interpreting it that way based on what you understand on what emotion is from your culture, right? But when they were speaking, they will be with a lot of expression. In contrary, when you speak to people from East Asia, like Taiwan or Japanese, they don't speak like that. And Italian, when they speak, there is also this they speak over one another. There is an overlap of speech. Before I finish, the other person speak, cutting my conversation. And that is considered to be good for them because you're showing interest in the speech. But for the Japanese, that is considered as rude. Okay, so this kind of thing. All right, so here we use simple sample data size to do the transplantation. For more information, please, I also put some the sources here so you can do. Similarly, I sent a student somewhere in 2016, 2017 to Spain to work on a similar project, but this time to induce emotion in a Malay text-to-speech system. All right, but she worked with the Spanish. So we work with the Spanish, but it's a Malay text-to-speech system, and we call it Emotion Malay Online Speech Synthesis, which nicely gave this short form of emosi. Okay, so this was by Chai ID. She was just a final year project student, and she did a very good job. So it was you can find it in lecture notes. Basically, the Malay text-to-speech system at that time, it was very robotic, and then we put in some emotion in it, and we make sure that it matches with the Malay emotion. So that is where culture comes from. It's very, very important. Yeah. Okay, this is another interesting study that we did on 3D emotion recognition. Usually for facial recognition, they don't use 3D. Yeah, they use 2D because it's easier. It's kinder to the computational cost, for computational cost also. All right. So what we did was we tried to recognize or detect these 7 big emotion. This is known as the 7 big emotion. Neutral is also considered an emotion, by the way. But for the 3D emotion, it can also recognize depths when the face moves. So that means when the face is at this side, at the side, you're able to say what's the emotion of the person. And when the person is looking at, at a sort of tilted angle, you can also know what is emotion. All right. So we had quite a high recognition rate. You can read it here at the source. And another work that we did was on biometrics. This is quite an interesting, and probably I would say it has quite high citation, where we try to recognize emotion, but this time to verify who is who. So biometrics to verify who is who, correct? So to verify whether Shahira is Shahira, whether Dr. Sakina is Dr. Sakina, all right? But in here, we have added the challenge. One is to add occluded emotion. Occlusion, not emotion yet, occlusion. That means synthetic occlusion. So for example, someone is wearing hijab, for example. Not hijab, what do you call? The veil on the face, like burqa, something like that. Okay. Or someone is wearing the glasses, sunglasses. It's not easy to recognize a person when they are being covered at the eye area or the mouth area. And on top of that, we added expression. If you see these faces, they are all in certain expression. So it's something like this. Imagine that I'm wearing burqa, niqab. Okay, let's say I'm wearing a niqab and I'm smiling, or I'm angry, or I'm surprised. Okay, so in this condition, we are supposed to detect, the system is supposed to detect who is who. Okay, and we managed to get, alhamdulillah, a quite high recognition rate also. So it's also published in one of the journal paper. Now, this is also an interesting study done by my student, a master's student, where we try to, nowadays we cannot do this anymore because it's so hard to get the data from social media. Yeah? They have blocked, or either you have to pay, like for example, X, Twitter. Before that we were getting data using API, but nowadays you can't do that easily. What we found out is that, so this student, what he tried to do is, we took all this data, we took structural data, we took textual data, and we took some data like some image data as well from the display pictures. And we try to investigate whether people are people are how they are, as in real, as in when they are, in social media. So do they have a social media life and also real life? Apparently they do. And interestingly, Malaysian women on social media, on Facebook, not social media, okay, because this study was done only on Facebook. So Malaysian women on social media are found to be more neurotic. So this student used Liuk, actually. Liuk is a dictionary that where you can use a Malay, we can also build up a Malay emotion dictionary that matches with certain words. So he built up this dictionary. It's called LIWC, but pronounced as Liuk, okay? And this is the finding. Right. And also uncertainty through face and shyness in smiles. These are all the students' work where we try to detect uncertainty through face, because, Asian students usually, when we ask, do you understand? They don't say anything. Or sometimes muka berkerut-kerut, you can see the foreheads going like this, going like that. So, okay, so we try to detect uncertainty through face, and also shy. We Asians are known to be shy, right? We are all shy. Are you all shy? Are you all shy people? Because we have very high humility, and so we are very shy. So shyness in smiles. So the way people smile also indicate different emotion. Sometimes they smile, kita kata senyum sinis. They try to be sarcastic. Sometimes they try to be genuinely happy. They try to show the genuine. Sometimes they just shy, right? And this is not really studied by the West. Okay, the shyness in smile, the study of shyness. This is very interesting. And of course, we use a lot of fundamental findings from social science papers as well, and also social science colleagues, which has given incredible insights to what shyness is in Asian culture. Okay. Okay, these are some of my current research, which I would like to share. Current research meaning now. So I'm concentrating on two big research right now. The first thing is trust modeling at zero acquaintance. So first we started with voice only. Let me explain a bit. This is a cross-cultural study where we investigate the trust level of individuals from different countries. There's Yemeni, there's Hungarian, there's Malaysian, there's Nigerian, but we have split the study into two. One is using voice only, and the other one is using YouTube video. Okay, one, we extracted the voice only from the YouTube video. So what these people, and these are, the video is a benchmark YouTube video called OMG, 1 Minute Gradual Challenge, OMG. All right, so it's a benchmark video. So people have to watch. The first phase is they just have to listen to the voice where they couldn't see the person in the video. And the people in the video are all mostly from North America, okay? And the people who listen, the listeners to these videos, they do not have any acquaintance. That's why we call it zero acquaintance, meaning that those who are they listening or they're watching are not actors, they are not sportsmen, they are not politicians, they are not people who they know. Because if you have this context, your perception can be different when it comes to trust. All right, for example, I already know Dr. Intan for a while. So I do have certain level of trust for her. Okay, so this going to, if I am asked to do the study watching Dr. Intan and ask whether I trust her or not, in different way, you have a set of questions, and my findings or my answer would be biased. Right, so that's what I mean. And here we found out very interestingly that those with accent, especially those American accent, by Malaysia are found to be more trustworthy by Malaysians, because the one that listened were just Malaysian for the voice only part. And then we move on. So that means sometimes I think maybe I should talk with accent, to have some trust among Malaysians, right? But we moved on one step further to use face, but there's a limitation because these are acted benchmark video. All right, so I wouldn't say that it fully represents, but anyway, we just want to see some patterns. So for some patterns, this is valid. Now, just watch this video of this man speaking. This is an acted video by an actor. We took several videos, not just from this person, but there are women, there are Asian-looking person, there are Black-looking person, African-American. Okay, this is a Caucasian-looking person who speaks this way. Please listen.
Kids are talking by the door. 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 Dogs are sitting by the door. Kids are talking by the door. Dogs are sitting by the door. Kids are talking by the door. Dogs are sitting by the door.
All right, I'll stop here. Okay, I'll stop at a very angry speech. So you have some idea of what people have to watch and rate. So what we tried to do was to model trust based on people's perception. And the people that are watching are from Hungary and from several countries. But we have split the work into two parts. One is just using Malaysian and Hungarian, because I have sent some students to Hungary to do this work. And we model trust based on people's perception on these several features, such as attractiveness of the looks. Sometimes you'll be surprised that someone yang lawa sikit, the one that some people that looks, a little bit handsome or prettier than average are considered to be trustworthy. You'll be very surprised. We only know when you do this kind of investigation. And also through the expression of the person, how the expression of the emotion of the person. If someone is overly showing expression, do you trust the person? Or if someone not showing emotion at all, do you trust the person? Okay, so imagine if you are academics and you're teaching, you're going like that and speaking without any tone, and how do you engage with your student? Because the student not only need to engage with you because they like the way you speak or they like the way you move, but they need to have certain level of trust to be engaged to you. And a lot of people do not realize this as well. And also through voice quality and articulation of speech and gesture. Okay, but for gesture, we are not using this corpus. Okay, because people cannot see the gesture in this corpus, only the face part is visible, right? And if you notice this video, the person is speaking with using not emotionally inherent sentence. That means the sentence are neutral sentences. So you cannot actually say that you trust the person because the person say I love you, or because I'm trustworthy or something like that. It's a very emotionally inherent sentence, very neutral. So it's not about what the person says, but how the person says it. Now, interestingly, this is the result. All right, between Malaysian and Hungarian, we did a study. The results show that for Malaysian group, interestingly, expression of emotion contributes to perception of trust. This is statistically significant, okay? Statistically significant at a 5% alpha rate. But this is not the case for the Hungarian group. For the Hungarian group, either you are being expressive or not, doesn't matter. They are looking at other cues, okay? So similarly, we have other results for Yemeni group and mixed culture groups such as Africans and other Europeans. And if you're interested, these are some of the publication. The latest was, I think, in 2023. That was in IEEE Access, and the rest were in some conferences, okay, especially EBA speech. And this was the first study that was done with the final year project student who actually also went to Spain to do the work. Another work is on cyberbullying, a recent work, which I find it to be very interesting. Very simply, don't worry about not understanding what is being said here. Very simply, most of the cyberbullying work are using main post. All right, they are not taking into consideration what the bystander or onlookers are saying. In traditional bullying, we also consider the onlookers or the bystander. They play a lot of roles. They play very strong roles, whether to instigate the bully or whether to defend the victim, right? But this is not seen online. To use with computers. We are not using, I mean, so far there has been no work as long as, for as far as our concern is, that have been working with bystanders. Okay, so what we did was we tried to analyze the bystanders text also together with the main post to try to see whether we can enhance the detection of cyberbullying. Hopefully this is a groundbreaking work, because we also have some data set that we came out, and the data set is being referred to as a benchmark data set. And finally, what we found out is by using bystander feature, by using the bystander roles, we managed to increase 60% detection rate above and beyond chance. This is the result, bystander information. Don't worry about, okay, the next one. The next one is just showing the mechanism. All right. These are some of my old works where we tried to put some Spanish culture in the guide of museum, effective home agent, and also effective Nemo Hippie. This was actually a hi-fi system. We call it Hippie there in Spain. It's a hi-fi system where it can actually detect people's emotion, and we put in some face, virtual face, and it can actually speak in an emotional way, but Spanish, all in Spanish. This was also what I did for my PhD very, very long time ago. And this was a work that we did with with UPM and also with JAIS, Japan Advanced Institute, another interesting study where we try to use, it's a cross-cultural voice or vocal perception, utterance perception in Spanish. And we asked people of Spanish region, Japanese, Chinese, Vietnamese, and Malay to listen to these Spanish utterances. The utterances are in Spanish, and to see whether they can detect the emotions well. And you can see here, Spanish, of course, they can detect the anger very well because it is, in Spanish, the words are in Spanish. Of course, they can understand what it means, right? But for the rest of these people, of the nations, for a nation from Japan, Chinese, Vietnamese, and Malaysian, they cannot understand. So, but interestingly, for neutral and sadness, they can detect it well. That means they have a high recognition rate for neutral and sadness, but not for the rest. Okay, so this is interesting when we want to build certain systems like conversational agent, we need to consider this. Sometimes it's not what is being said, again, it is how it's being said. Okay, So this study is the cross-cultural perception of emotion using voice, and you can also find it in one of the publications. And very shortly, now I'm going to go into culture and computing. And usually, basically is East versus West. All right. When we are looking at difference of culture, what I try to do is to cluster between East and West. Of course, there's certain subtle, in between. And what we need to understand, and I think from some of the work that I have shown, you probably would understand that one size model for culture does not fit all, because emotions are actually recognized and expressed differently from culture to culture. And if you see here, in reality, in the real world, we don't really show full-blown emotion. Most of the work nowadays are only, looking at full-blown emotion, but we have moved to subtle emotion, and subtle emotion can be culturally specific. Okay, some example of emotion can also be annoyed, tired, and flow, and this can also be culturally specific. And subtle emotion are more difficult to be detected because there is no clear transition boundaries across the signals that we are looking at. So we are looking at segmentation problem here. And this also reflects in NLP, like sentiment analysis, where there needs to be a transition from polarity detection, positive, negative, to multi-class fine-grained emotions. Okay, and we also have masking problem, and later I'll explain to you what is masking. Now, look at this example. I do not know. Okay, I hope that it has appeared in your screen as well. Please look at this example.
When you want to say yes, at that time, most of the time, Indian people are using the body language. Yes, it's possible. मैं करूँगा. आज ही करने वाला हूँ. It's possible. मैं करूँगा.
Okay, so this is an Indian yes, right? Yes or no agreement. So imagine if you're coming up with an agreement model, if you want AI to recognize your agreement, it's supposed to be like this for you, for your culture, in your region. But for the Indian, it's like this. So if you use their data and you want to train using their data and you want to use it in our system, it's not going to be suitable because it's going to confuse frantically the system, because the system is going to say this is yes in our culture when we are saying like this, right? And also code switching, especially in sentiment analysis, we have to consider this. We have Manglish, we have Singlish, and like something like cuba try, or sarcasm. So when we speak in Bahasa Melayu, sometimes, not sometimes, I think all the time you're not using a pure Bahasa Melayu, right? So we need to have a way to detect this code switching as well, Manglish, right? These all are important to make up culture-sensitive system. And also maybe this is something that you have realized, but as a scientist in my team, where we are trying to change things into machine-readable form, we realize it even more clearly that verbal display rules are very important. What we realize is that, you have politeness in certain culture that uses inclusive language or the way of addressing. For example, we call our sister or older brother as abang long or abang or kakak, right? Or even when you speak to people who are older than us, we say auntie or uncle, but this is not accepted in the West. It's considered very rude. And the Easterners usually, especially Southeast Asian, we use a lot of verbs compared to noun. When someone have invited you to their house and asked you to drink tea, kita kata apa? We say, minumlah lagi, makanlah lagi, minumlah lagi, makanlah lagi, minum, makan, drink more, right? Take more, have more. So this is actually verb. But when you go to maybe to the Western region, they're going to say, drink more, where they say, have more tea or more tea, something like that. So these are verbal display rules that we need to consider, okay, when we're building systems. So when we use this when we are trying to just merely translate to English, for example, something in Malay, we are trying to translate to English, it may be considered rude, or something that is English that we want to translate to Malay, it is considered rude. Or when even, you imagine you have a conversational system that say, mahu teh lagi, instead of minumlah lagi, something like that, as simple as that. And also this, all right, some considerations. Frustration has no exact equivalent in Arabic, and you have Schadenfreude in German that actually translate. It's not translatable in English, but then I think in Malay we have it is dengki, yeah, that means feeling happy for some other people's misfortune. And no word for emotion for Tahitians and Ifaluks, okay. And Inuit has no anger. This is by Briggs, who is an anthropologist who went and stayed with them for a year or so, and she found out that Inuit has no anger. They do not know what anger is. And lucky and considerate are emotion tags. So this is important for sentiment analysis. Lucky and considerate are emotion tags for Japanese. Okay, and amok and latah, these are two very specific emotion of the Malays, or maybe Indonesian. And the word amok is a borrowed Malay word. Okay, and when you talk and in English, when you try to build a system in English, or when we try to take English system as a base, you will realize that the way of addressing is only you and I, which is not very suitable for Malays and also for some European languages, because there are some European languages like the Dutch, like Spanish, they don't just have you and I. Just like us, we cannot say kau to our parents, right? We cannot say, we have different way of addressing. We also say saya, sometimes aku, sometimes kami, sometimes hamba, depends. So bahasa jiwa bangsa, language is the soul of the nation. So we have to remember this. These are also inclusive ways. All right. I mentioned about masking problem just now. Now, first, these are non-verbal display rules. You see, in Asian culture, we do not really actually show our real emotions on the faces, because sometimes we feel something, but we report. When we are asked about our emotion, we are self-reporting something else. This is known as masking problem. There was a lot of studies that have confirmed this. Okay, and when the second person that, for example, there was a study in Japan where they were asked to watch a movie, a very sad movie, so everybody was crying, right? But when they realized the researcher coming in and sitting there as an observer, then they stopped crying. They do not want to show that they're sad emotion. And when the researcher asked them how they feel, they say they feel okay, neutral, but actually they were actually crying, right? So this is what we call masking. We are not very, because we are non-confrontational culture. Because we are in a non-confrontational culture, we have a lot of masking. And for masking problem, we should use more physiological system, like thermal-based system, to check the periorbital area. When it's more hotter here, then the what is the actual emotion, or radio wave transmission. And also for the Western culture, usually for facial expression, we try to concentrate on the mouth region, because they use the mouth a lot to express the emotion. And for the Eastern culture, more on the eyes. You remember, I'm sure a lot of adik-adik di sini who loves to read manga, right? And you see manga, Japanese, they have slanted eyes, right? They have very slanted eyes, but the manga has very big eyes in there. Why? Because they're trying to show the emotions. The emotion are being shown in manga, even in their animation, right? So this is something interesting. And this also translates to emoji. The mouth region used by certain culture, okay, and the representative of emoji for the eyes, showing emotions. So this is, if this is smile, this is smile. This is green, this is green. This is wink, this is wink, right? Sad, sad. Crying, crying, right? We never really thought about it, but when you're in AI, all this have been translated. You have to be translated, like I said, to the systems, and so everything needs to be readable by a computer, and so there needs to be some coding or learning capacity. Okay, there are more display rules, but I'm going to skip, so I'm going to go here. Importantly, we spoke about similarity effect. In 2004 and 2008, there were studies done, and they found out that on personality and also sentiments, all right, in certain studies, like for example, in this medical avatar studies, right? These are medical avatars in the US. They found out that curly hair and dark complexion avatars are not being favored as compared to white skin, straight hair avatar. Okay, this was real, all right? So perhaps in North America and in some other places of Europe, there's also what we call inferiority complex effect that are usually linked to racism. You may be familiar with this test. It's called doll test that was done in early 1960s. So if here you see similarity effect, you know, the same as what I was explaining to you earlier with my study on the tutor, synthetic tutor. This one, they did a synthetic medical avatar, an agent. Here, there's similarity effect. That means people from the same similar culture prefer people who are in the same similar culture as their avatar, you know. But in this is the opposite. Even if you are African American, in this study, based in segregational study back in 1960s, the child, when asked, you know, what do you prefer? The child say, I prefer, or I want to be white. All right. And interestingly, this study, shockingly, in fact, this study is being repeated in 1980s, 1990s, and I think the most recent in 2016 or 2017. I don't remember, with the same result. So history is being repeated with the same output. All right. You can actually read about this. I put some sources here. And here also, interestingly, in Israel, male drivers do not like female voices in their GPS system because they feel like they don't want to listen to women. Okay, we don't take instruction from women. All right. Okay, so one challenge that I want to talk about is acted emotion versus emotion in the wild. When it comes to AI-based emotion research, training corpora is the biggest challenge to find real representative of wild, training corpora of emotion in the wild, we call it. So between acted emotion corpora that are open source and laboratory constrained, and the real versus real-time emotion in real environment. Okay, of course, we still use the acted emotion. We still use laboratory constrained signals. But the best is to actually get emotion in the wild. So now we're moving into more natural corpora. So that is more representative. The output is more representative. So if you use acted emotion, there will be certain mismatch when you train using the acted emotion and applying the model onto real situation. That means the ground truths, you're trying to find the ground truths may be grounded, but in some ways, but not the truth. Okay, so it's not really representing real world. So the output can be a bit more acted as well. Okay, and we are moving towards the end of the presentation. This is one of my favorite quotes. The question is not whether intelligent machines can have any emotion, but whether machines can be intelligent without any emotion. So please, even human, right? We can only recognize emotion. We are said in a scientific paper that we can only recognize emotion at a 60% detection rate, 60% rate. All right. So imagine if you're trying to make machines do this, and let alone if you're trying to train data from one culture and then fix it into another culture for recognition. So no one size fits all model. And last but not least, humor. I think humor could bring a dash of humor won't hurt AI. Okay, so this is something that I found out in the social media, just to share. When was the exact moment you realize humans were not going to make it as a species? Open box before eating pizza. Of course, you have to open box before eating pizza. We are not trying to rely too much on AI here, and AI is not replacing human being, but we are trying to make the system more adaptive. Okay, the reason for AI is to make the system more adaptive. And these are some of my team members, some students, mostly team members from Europe, team members from Spain, from Hungary, from Italy and Poland, and from Saudi Arabia, Yemen, Malaysian team. I couldn't put all the pictures here, and I apologize for those who are listening who are not in this picture. Last but not least, I hope that you have got the two messages, the function of emotion and also the function of culture in AI systems. I would be very happy to answer your question. Thank you very much for your attention. Thank you.
Thank you, Dr. Shahira, for the great sharing. Now, let's move on to a Q&A session. Audience can leave any question on the comment section.
And I think I have exceeded a little bit. I've exceeded 5 minutes or I finish in time. So I'm not sure. Hopefully I finish in time. And hopefully we have some...
It's okay. It's okay.
It's okay? Yeah. Thank you.
Doctor, I have a question.
Yes.
You did mention about the masking problems. So how actually I got to detect the emotion by before? Is it like you said earlier? Indians say yes by shaking their head, and also when they say no, they also shaking their head. So how they differentiate it?
Well, I actually did not finish the video. They when they say yes, it's like this. When they say no, it's like this. So they have a certain signal. We could actually train the system to understand the signal for agreement, for example. So it's not that difficult. But the point is not to not to use the same training to fix it into our model, to our systems here, for our use. That's going to confuse the system. It is not masking actually. That is not considered as masking.
Okay.
I hope I answered you.
Okay, thank you. Okay, we have a question from Ali Bahzat. It asks, how can we better set our emotion with situation in various culture? Yeah,
I don't really quite understand what you mean by better set your emotion. But what I think the questioner means is how do we actually adapt our emotions in different culture. So there is this saying in Malay, masuk kandang kambing mengembek, masuk kandang lembu menguak, or something like that, right? So I agree with it and I disagree with it. It just means that for me to translate the saying, so when you enter, for example, a shed, kandang kambing kita kata apa? When you enter a lamb shed, then you will have to sound like the lamb. Okay, so when you go into a buffalo shed, then you need to sound like the buffalo. For me, you don't have to overreact. No, you don't have to overreact. Emotion it's just that however your emotion is, you just have to, the only thing that you can do in a situation as a human being is you cannot control the situation. The only thing that you can do is to control your own emotion. So if you are in a very difficult situation, try to control the emotion, try to listen and not overreact. Of course, because when you overreact, at the end of the day, the situation doesn't matter. What matters is who have overreacted, and the person who have overreacted is the person who's going to be blamed. Okay, it's going to be seen as the wrong person. So to answer your question specifically, if you go into certain culture, then you need to respect the culture as well. But it doesn't mean that you have to jump out of your culture and become somebody from the person's culture. So you can still be true to your culture, okay, but at the same time you take what is positive from the other person's culture. Like when I talk to Japanese, I see that they have a very calm culture, so I try to learn from that, right? But I also see that being too calm in certain situation is not going to help, because people are not able to tell what we feel about it. So there needs to be a midway. It has to be modest. Even in Islam, we are asked to do things in a modest way. So just be modest, not too extreme in any situation. That's my answer. I think there's some lag here because I see question coming in, but a little bit late. So one more thing that I would like to add is that in this affective computing and cultural computing, I used to argue with some of the partners in the West that one size fits all doesn't exist, because usually from the West they ask to use their systems, their models that they try to put in other people's model. And I also have actually I missed one slide of one of my students that was working in zero trust adaptation, ZTA. So in this zero trust adaptation, we try to see, it's a cybersecurity model where the concept is never to trust, always verify. So it doesn't matter how long you have been in an organization, you still need to sign in to access certain systems. And what we found out is that the national culture and the organizational culture has been ignored by Emirates in Emirates. Okay, this is in Emirates. And that is why the zero trust adaptation model are not being adopted as fast as they want. So this also has got to do something with culture. Okay. And everything needs to be proven scientifically. So this is an empirical work, and to put out emotion completely from decision making is not correct. So you need to have some kind of emotion for decision making, for correct and logical decision making. Otherwise, we are like autistic, right? So that is hopefully that is my take also for today's talk. Ada lagi soalan ke?
Okay, we got a question from L. Eddie. Emotion is indeed an interesting area to explore. What motivates you to continue exploring it?
This is a very intelligent question, actually. What motivates me to explore it? Because emotion, because you already said it yourself, it's indeed an interesting area to explore. That's why I will continue. That is one of my motivation. So when I started from my master's in UM, I started with emotional synthetic speech, text-to-speech system that we work with MIMOS Malaysia Berhad for my project, right? And MIMOS, what MIMOS was building at that time was TTS, Malaysian text-to-speech system. So when you type, it will translate into speech. Okay, and the other way around also, speech translated into text. So this was at that time probably very, very advantageous for those who have who are, I wouldn't say disabled, those who have less ability than us, like those who are deaf and who could not speak. At that time, we realized that the text-to-speech system was very, very robotic. The speech was very robotic. Tak ada tone, ya, tak ada tona. It was very robotic. So we were asked to infuse emotions into the text-to-speech system. That's how I started. And I thought, wow, this is really very interesting. especially this is multicultural. Another motivation is that because this area is very multicultural. So I have to work with psychologists, I have to work with social scientists, I have to work with statisticians, I have to work with engineers. And usually I realize that they have a different view, okay? Social scientists or psychologists, they're very stemmed with the underlying findings from social sciences. And sometimes it's not easy to translate this 100% into machines, into AI systems. And that is also a challenge that motivated me to do so. And you need to have people who are very good researchers, who have good interpersonal skills, you know, to talk to these people from different disciplines, for them to be able to gauge information and insights to be brought into this AI system. So interpersonal skill is also very important. So people who are in this area mostly have very good interpersonal skill, and that is another motivation. And I hope I answered your question, Ellie, Adli.
Okay, thank you. Thank you, Dr. Shahira. So we don't have enough time. So we
Okay.
had like to express our sincere gratitude to Dr. Shahira for sharing her valuable expertise. A big thank you to all of you, the audience, for joining us today. Hope this wide talk sparked meaningful discussion and ignited your interest in the future of AI. So we look forward to seeing you at the upcoming Y Summit 2.0 at UTEM 2024. Thank you all.
Okay, I think that's all the time we have, even though we may extend the program a little bit, but I think that's all right. Anyway, a thousand thank you for our speaker, Dr. Shahira Lebai Lutfi, and a thousand thank you for anyone that participate in this program. And, you know, also thank you for anyone who listened intentionally. Now, before we all take a break, I would like to remind our participant to sign the register form and give us a little feedback on how do you think about this program. My team will provide the register and the feedback link for you in the comment section. Now, any students from UTEM? Because students in UTEM who listens to this program, we will give you a special QR code just for you. And that QR code is for your SMP marks. Now, I will give the audience about 1 minute before we take a break. And you can use that 1 minute to sign the register form and the feedback form. Thank you very much. 1 minute. Now, before we take a break, I just wanted to note everyone for our next event, and that is for our Y Masterclass. It will start around 2 in the evening, and for a meantime, Let's take a break, and I will see you all later. Thank you very much.
I am Faruza Amira.
Hi, I'm Gita.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Sakinah Si Ahmad.
Hi, I'm Khalida Jassi.
Hi, Assalamualaikum. I am Nur Intan Raihana Ruhayim.
Hello everyone, I am Nurzarin Zulkarnain.
Assalamualaikum and hi, I am Hamira Hania Abdurrahman.
Hi, my name is Farizana binti Hamzah.
Hi, my name is Nurul Akila.
I am currently a data scientist at ST Microelectronics and Chief Operating Officer at Ever AI Technologies.
I'm also the founder of startup Generative.
Currently, I'm Associate Professor in the Department of Intelligent Computing and Analytics, UTM.
I'm also a statistician at DOSM.
I am currently a Senior Lecturer at the School of Computer Sciences, University Science Malaysia.
Currently, I am a Senior Lecturer at the Faculty of Information and Communication Technology, University Technical Malaysia Melaka.
I'm also a senior lecturer at the Faculty of Industrial Management, University Malaysia Pahang.
And currently a second year student of Bachelor Degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Currently a final year student of Bachelor Degree of Computer Science in Artificial Intelligence at University Technical Malaysia Melaka.
Women in AI is awesome,
Engaging,
remarkable,
Passionate and dedicated.
And a great platform for building friendships.
So let's join Women in AI Malaysia Summit.
Assalamualaikum and welcome back for the second session, and that is for our Why Masterclass. Now, I hope everyone have a good lunch during our break. My name is Imran and I will be your moderator for this afternoon session. Now, before we start our next event, take note that this is the Why Masterclass. Now, people might be wondering what is this Why Masterclass and what's the difference between Why Talk and Why Masterclass. If we read the poster, it says participants will learn to leverage Intel's open source AI tool to build and deploy optimized video analytic and generative AI. This session will also cover the practical application of this tool to harness the power of heterogeneous accelerators, enabling participants to implement cutting-edge AI solutions at the edge. At the end of the program, attendees will gain hands-on experience and insight into the efficient utilization of Intel-optimized technologies for advanced AI development. Before we start the program, I would like to introduce our speaker, Dr. Ramesh Perumal. A little bit about his background for the audience. He accomplished IT professional with a PhD in electrical engineering, equipped with 10 years of experience in software development, specializing in architecting edge AI video analytic applications. He is also proficient in data analysis, neural network optimization, and adept at deploying containerized AI workloads on edge devices and leveraging diverse hardware accelerators. He is also demonstrates success in steering AI projects and fostering seamless collaboration across interdisciplinary teams through strong communication and presentation skills. And for that, I welcome our speaker, Dr. Ramesh Perumal. The stage is yours. Thank you.
Thank you, Bram. Thank you. Hope you hear me. Okay. Can you hear me? Okay, great.
Loud and clear, sir.
Thank you. Thank you, everyone, and the president and all the team members behind the organizing committee of Women in AI Empowerment. I'm very happy to share my contributions or share my learning in edge AI computing through video analytics and generative AI use cases. I would like to have this session as an interactive and also not only covering the theoretical and also the hands-on sessions with a few demos on video analytics use cases like image classification, object detection, instance segmentation, and the most trending LLM chatbots with and without RAG. What is the purpose of RAG? I would like to cover these topics. Let me share my screen. Let me know if you could be able to see my screen over here. Can you see my screen? Okay. I started to share my screen. Okay. Thank you. So let me know. Please stop me if you'd like to clarify any doubts during this session. Thank you for having me. So the session is on mastering video analytics and generative AI use cases for the edge using Intel optimized AI tools. So I've been working as a AI solution architect at Intel in Penang, Malaysia. Once again, thank you very much for the organization committee for inviting me to share this topic with a plethora of researchers, faculty members over here. I hope this session helps you to accelerate your development time in your research or any of your industrial use cases. The agenda for today's topic. So I would like to cover the AGI use cases, representative use cases across different verticals, and the motivation behind using OpenVINO toolkit that I will cover in the slides, and cover the various components such as model optimization, model quantization, how we could deploy in a streamlined way using OpenVINO runtime API. Then the sample of generative AI use cases, the existing hardware infrastructure that is available at free of cost. Some of the platforms are available at free of cost to evaluate the performance of your AI workloads. And then with demos, including object detection, instance segmentation, image classification, and LLM chatbot using OpenVINO and LangChain framework. So this slide actually helps to summarize the edge AI computing or edge computing environment. So why there is the necessity for edge AI? So instead of by moving the inference execution from the cloud to the edge devices, helps you to save the cost, the infrastructure, networking, or it could be cost involved in using the cloud, or cost involved in using the network to communicate the data between the production environment and the cloud, and more importantly, privacy. So we could have the model. It could be a model or data. You could make use of. You could protect the model as well as the data when you deploy the application or when you execute the inference on the edge devices. So let's say we have the industry, and let's say we have the data generated. It could be anything. So if the inference is executing on the edge devices that is around the data generator, then actually there is a outline of edge computing. Why we are going for edge computing? So you could make use of the resource constrained edge devices near the data generator, and you can execute the inference directly on the devices as and when the data is generated. So it's also useful to reduce the latency involved in executing the inference. Or, for example, if you execute the inference or deploy the AI applications on the cloud, you should also consider the latency in transferring the data, between the data transfer between the cloud and the data generator. So these are the use cases that we come across in our routine life. For example, traffic light, video analytics, security, video surveillance use cases where you get multiple video streams from the cameras. You may need to use deep learning to detect the object, to count the persons, to count the number of persons standing before an aisle or a particular layout store in a retail stores, or something like, if you, in case of digital signage applications, you might be seeing you may be having a monitor near the retail store aisles, and you'll be wondering what is the necessary for this digital signage. So in those cases, the ads or promotions might be displayed based on the gender, on the age, depending on the number of persons in the count. The promotions and the offers could be adapted according to the environment. And license plate detection, like for example, it could be used for many of the purposes. For example, security barrier use case, I just need to detect the plate when the car is standing before the security barrier. Or traffic surveillance, it could be used in this case, the camera, the camera execute the inference, and as well as the cars may be at any position. For example, in the security barrier use case, a car might be standing in a static position. In case of traffic surveillance, the car might be in any direction. So there are several challenges in these use cases, how to detect the license plate when it is not in the frontal view. And autonomous driving use cases, for example, here you can also, in case of drivers, with drivers also, you could be able to estimate whether the driver is busy with or using phones, or whether the driver is concentrating on driving, or any kind of issues that could affect the driver safety. And industrial automation use cases, using robotics to automate the movement of goods between in the factory side, or predictive maintenance. It could be anything. For example, estimating the quality of the machine from the noise generated by the machine. It could be anything. So there are multiple use cases, video analytics use cases as well. And moreover, we also have generative AI use cases that helps you to create the content, human-like content, generate the human-like content and respond to the human inputs, chatbots, or text to image. For example, recently there is a tool called Sora that converts text to video. It could be anything. So the generative AI use cases are so trending recently, especially in the chatbot side. So today in this presentation, we will see what are the challenges we need to come across when you have the trained model to be deployed on the edge device. Because if you have the trained model, with the trained model, you could have used any supercomputer or discrete graphics or any computationally expensive hardware to train your model. However, you cannot expect the same hardware to be available in the production environment, where you might be looking for resource constrained devices. So what are the gaps to be filled, identified? How could we leverage, make use of the existing tools to optimize the model and deploy the model in the production? This is the major motivation behind using the toolkits such as OpenVINO. So these are the challenges in model deployment. So you might have a trained model, but you may not have the same hardware acceleration capabilities in the production environment, where you'll be using resource constrained devices. Sometimes the trained model may perform poor. You mean in terms of inference speed or latency, you may be experiencing a longer latency when you deploy the model on resource constrained devices or any portable embedded devices. So integration challenges. What is the availability? How about the availability of end-to-end development workflow? Let's say you have your trained model. What are the steps that are required to optimize the model and deploy the model into your main application, and how to monitor the performance of the model in case of any performance degradation? What could be the tools used to retrain the model? What is the right time to trigger the retraining based on the performance of the model? Because you cannot expect the same performance over the time period. You might have used the existing data in the past to train the model. However, due to several constraints and challenges, there may be changes in the data. The data might evolve, and that could affect the impact, that could affect the performance of your model. So in these cases, you need to continuously monitor the model. It's not like it is sufficient to deploy the model and the story ends there. No, another story begins there, because you need to monitor the performance of the model, how it is, how you could maintain the same performance in terms of accuracy, how it is detecting how it is detecting the persons or objects, even the data changes. You need to monitor these parameters and trigger the retraining when required. And no one size fits all. Sometimes, there may be diverse requirements for the use cases. Like some use cases may demand real time requirements like very low latency. Some use cases may require higher throughput, higher inference speed, number of streams processing per second. So considering all this, we need to have a one-stop place to deploy, to optimize, deploy, and productionize your AI workload. So this is the motivation behind using OpenVINO toolkit. The term OpenVINO stands for Open Visual Inference and Neural Network Optimization. Let's see what are the highlights of this tool first. Truly open source, so there is no need to pay money. You can use this tool without any license, and cross-platform support, pre-license with the you can use this tool in your production environment. So to reduce the cost, there's the first point. Cross-platform support. There is something very interesting with this tool is you need to develop a single version of your source code to execute the inference across different accelerators. For example, if you can use the same version of the source code to execute inference on CPU or integrated GPU or discrete GPU or NPU recently in the Intel Core Ultra processors. And AI-DL inference and even though this toolkit was developed initially for computer vision workloads, however, there have been substantial changes in the support given to this by this toolkit. For example, it could support vision as well as non-vision workloads such as generative use cases, LLM chatbots, the recommender systems. So many use cases beyond the computer vision as well. And performance optimized is also support a limited set of third-party hardware, including ARM, and it is compatible across. It could be suitable to a wide range of devices ranging from edge to cloud. Yeah, it's important to scale up the performance with this toolkit, and it's possible with this OpenVINO toolkit. These are the three different steps in the OpenVINO toolkit developer journey. First is the model selection. If you have your own model which is trained on PyTorch or TensorFlow or Keras or any framework, it's fine. It supports several different frameworks. If you don't have your model, you could import the model from Open Model Zoo that contains more than 300 models and several demos and reference implementations for you to get started. And it's also compatible with, it provides an interface to access the Hugging Face repository through Optimum Intel module. And we have something called Intel Getty. This platform helps you to quickly train the model on the limited set of, given the limited set of data, and also helps you to automatically annotate the images. If we annotated the images, initial set of images, so this is quite helpful to accelerate the time training as well as the deployment. And it helps. The end result is you will get a optimized model using OpenVINO that you could use finally you could use OpenVINO runtime API to deploy your model. So once you have your model optimized with model ready, whether it could be your own model or from Open Model Zoo or any other third-party repositories, provided those layers are supported by OpenVINO toolkit, you can use OpenVINO model converter. There is a convenient OpenVINO model conversion API that helps you to convert the model from any of these frameworks into a format called intermediate representation. This intermediate representation contains two files. One is .bin that contains the weights, optimized by model weights, and another one is .xml that is the model topology. To execute inference, the API needs XML and bin file. It is sufficient to use any of the model path, and you can execute the inference. The purpose of the main advantage of this IR format is, first, the model size is reduced compared to the original framework after optimization, and this helps to accelerate the performance of your model across the Intel platforms. This is one of the main advantage, and the leverages the optimizations being used in the model and introduced by the model converter, and that could benefit the accelerate the performance of the model on the Intel platforms. So recently, sometimes it is also sometimes you don't have to move away your code, or you don't have to change your code more. So in those cases, actually, it is also possible to use the TensorFlow .pb or PyTorch.pd model, and you can use OpenInno as the backend here, and you can also directly OpenInno directly support this model as well. However, it is recommended to convert the model to IR format if you'd like to achieve the, if you'd like to improve the performance. Yeah. And if you think that usually the models or the model layers, the data type of the model layers is 14 usually 14.32 FP32 precision, and in many cases, when you deploy the model on the resource constrained devices, we cannot meet the target performance. Sometimes, if you want to achieve 30 frames per second or something like that with the production with the edge device, if you think that if you're getting 10 or 15 frames per second, it is also possible to accelerate the performance by compressing the model weights, as well as the quantizing the data precision from data type from floating point into integer 8. So when you reduce the precision from a floating point to integer 8, basically the model size is reduced once again compared to the floating point, because integer requires less computational resources compared to the floating point. This further accelerate the performance of your model on the Intel platforms. And the OpenVINO toolkit comes with a set of tools or supporting frameworks. One of them is the Jupyter notebooks. It's called OpenVINO notebooks. It contains a lot of ready to run notebooks, optimization techniques, demos that could be used to you could make use of these notebooks to get started quickly, so that you could be able to reduce the development time. In this case, actually, you don't have to write the code from the scratch. You could make use of these Jupyter notebooks to make a few changes according to your use cases. And finally, once you have your optimized model ready, you need to deploy the model on the edge device. There are two scenarios. Maybe first, you may have to deploy the model on an isolated edge device. You can use OpenVINO runtime API that is available in Python, C, and C++ languages, and this helps you to integrate the deploy model into your application. And there is in another scenario, you might have to build a server client architecture. In this case, you may have a own model server, computationally expensive hardware, and you could save the model over there, and you might be having thousands of resource constrained edge devices. So when you need to execute the inference, the edge devices will send request to the OpenVINO model server, and in turn, this execute the results. In turn, the server sends back the inference results. So in this way, you could be able to scale up the performance even with the resource constrained devices by having a single OpenVINO model server. This is all about the deployment options. And one of the important features of OpenVINO toolkit is write once and deploy anywhere. You could see here it supports inference on CPU, integrated GPU, discrete GPU, and recently neural processing unit (NPU) in the Intel Core Ultra processors. So you don't have to change your source code every time when you change the accelerator. It is just sufficient to have your single version of your code, but still able to support still able to execute inference across the heterogeneous accelerators in the Intel platform. This is something very great because you don't have to change the source code often. Any doubts in understanding the overview of OpenVINO toolkit? Any chats? Hope you're following me. So let me know if you have any doubts in understanding the overview, the different components of OpenVINO toolkit, or the motivation towards using OpenVINO toolkit for deploying the AI models on edge devices. I request the moderator to let me know if in case of any questions from the participants. Yeah. So here, just want to quickly take a look at the latest features in 2024.1. This is the latest version of OpenVINO Toolkit, and if you see the last 3 to 4 versions mainly focus on improving the performance of LLMs. Recently, Llama 3 was recently released before before a month, and OpenVINO supports it well. And we have the OpenVINO notebook also included to verify the performance of Llama 3 model on Intel platforms. And besides this, Mistral, Llama 3, 5, Microsoft 5 models, and many other models, Neural Chat and Chat GLM, and GPT models are also being supported by OpenVINO. So you could see the Lava next model. So they have recently introduced this notebook to help you quickly get started with video understanding or summarization. And also, more importantly, the OpenVINO toolkit also make use of the hardware-specific optimizations in the hardware. Let's say the Xeon 4th generation and 5th generation of Intel Xeon has this Intel Advanced Matrix extensions. So this toolkit has introduced sufficient more optimizations so that it makes use of this feature to accelerate the performance. And it also supports integer 4 and integer 8 versions. This is very important so that you could be able to deploy the LLM use cases on edge devices or your laptops without the requirement of discrete GPU or computationally expensive hardware. As I mentioned, if you don't have your model, you could refer to this Open Model Zoo repository, which contains 300 plus models across different use cases and verticals, starting from image classification, instance segmentation, gesture recognition, and generative AI use cases like chatbots and image generation, and also text-related stuff like text detection, recognition, OCR. So it contains a lot of models, demos, and reference implementations that are ready to be implemented. It help you to quickly get started in using the OpenVINO toolkit. So let me deep dive into the model conversion. Let's say you have a model trained on PyTorch model. You could make use of, there are two options. Either you could make use of the model conversion API and convert it into intermediate representation data. This is the recommended flow to accelerate the performance. There is also another way. You could also directly use the PyTorch model or TensorFlow model by using OpenVINO as a backend. These are the supported frameworks for direct conversion. However, the first approach, the option 1, is recommended to achieve the optimal best performance of your model on the Intel platforms. In case if you would like to quantize the model or compress the weights from like operations like pruning and quantization, you could make use of the neural network compression framework. It offers 3 different paths to basically to compress the weights or reduce the precision to further quantize the model, optimize the model. Post-training quantization doesn't require the entire data set that you use. Just need to subset of training images would be fine to compute the statistics. This is one of the easiest way to quantize the trained model. Let's say if you have your trained model and convert the model into intermediate representation, you could make use of this post-training quantization toolkit to convert the model from floating point into integer 8 precision. Sometimes, if you may have to convert the model, you may have to use, if you feel that if you'd like to use the integer 8 precision while training, in order to reduce the training time, you could make use of training aware quantization method. This helps you to this quantization aware training. This helps you to train the model with integer 8 precision while during the training itself. So this helps you to further improve the performance. Sometimes we may have to compromise the accuracy depending on the use cases of the model. So in those cases, you could use this technique to have a right balance between the target performance and the accuracy or other metrics. So here, this slide actually helps you to understand how the workflow of the model deployment or model optimization. So first you need to create a OpenVINO core and then compile the model and create the inference request. You need to set the input according to the model input shape. Because it's the input image may be three-dimensional, like height, weight, and number of channels. However, the model may be expecting something including the batch, 4-dimension. So you need to resize the input and to reset the input according to the expected model input shape. Then you can start the inference and post-process the results if required. The the OpenVINO toolkit offers the runtime API in C, C++, and Python languages, and this helps you to integrate that Optimus model in into your main application written in any of these languages. And moreover, this contains a lot of demos. You don't have to start from the scratch, and so that you could be able to make use of the existing demos or reference implementations and fine tune it according to your requirements. As mentioned before, I would like to highlight this feature: write once and deploy anywhere. You need to have a single version of your source code, and that is sufficient to execute the inference across the heterogeneous platforms. Like it could be CPU or integrated GPU or discrete GPU or the neural processing unit in the Intel Core Ultra processors. And OpenVINO is compatible to deployments on cloud, to edge. So this actually helps you to reduce the development time. If you are if you would like to deploy the model in the on the edge devices. And I would like to highlight the existing hardware infrastructure provided by Intel. The first two are offered at free of cost. The first one is Intel Developer Cloud for Edge. This is a cloud platform that helps you to evaluate the performance of your AI use cases, not only the inference performance. You could install the Python dependencies or any other dependencies of your application, and you can run the application on a wider range of hardware available, from Atom processor to Xeon processor or the latest discrete GPUs. So it's so easy to create an free account, and you could be able to. This is very important to find out the optimal Intel hardware before buying it, before procuring it. So and this is offered free of cost. And also similarly, we have Intel Edge Developer Toolbox. So this also helps you to evaluate the performance, optimize the model. It also, both the platforms, you could also import the LLMs. You can optimize the model into integer for precision, and you can evaluate the performance using the benchmark app utility. And the third one is Intel Developer Cloud, and this is mainly targeted to at model training, and we need to pay depending on our usage. This also supports all the latest Intel hardware. In case if you're looking for a platform to start training your model on the latest discrete GPUs or Xeon server, this is the recommended platform. Maybe I can show you. This is the Intel Developer Cloud. Hope you could be able to see my browser. Let me know in case if you couldn't see my screen. So this is the Intel Developer Cloud. You could create a free account also with the standard service that is offered at free of cost. However, if your objective is to train the model for a longer time on any of the latest hardware, you need to pay, and you can make use of this platform for model training. And this is like Intel Edge Developer Toolbox. This platform is you could make use of this platform to evaluate the performance of it. Let's say you have your trained model. If you want to optimize the model, yes, you can do it over here at free of cost. And in case if you want to develop and test or get started in training the, if you like to play with the existing AI applications, you can import any of these applications available on OpenVINO notebooks. You can import it. Let's say if you want to create an LLM powered chatbot, you can import the corresponding Jupyter notebook, and you can optimize the model, and you can run the entire application on the on any of the existing hardware. And if you like to evaluate the performance, you can make use of this option to evaluate the performance of the model on any of the available Intel hardware. So this is the existing a list of existing hardware infrastructure that is available provided by Intel for you to do the performance evaluation or the model training. To deep dive into the other components that could be of interest, that could be of that could help you to further learn the AI deployment, the deployment of edge AI use cases. I would recommend you to first have a look at the open window notebooks that takes you to several ready to run Jupyter notebooks. Like starting, we have something from image classification, detection, recommendation, generative AI use cases, text to image, and and LLM chatbots with RAG and we have so if you're interested in video analytics use cases, DL Streamer is the recommended one. This Intel deep learning streamer, shortly called as abbreviated as Intel DL Streamer, that helps you to accelerate the development of AI applications with minimal code. As you can see here, you just have to use the existing pipeline using GST launch. It is something similar to the GStreamer. It offers the building blocks that you need to fix together to execute your application. This is the option that helps you to quickly develop your production application. If you to quickly develop your AI application, as well as it's so convenient to evaluate the performance, and there are benchmark application scripts are available for you to evaluate the end-to-end performance. This offers you the building blocks for you to pre-process the image. Like you can make use of the integrated GPU or discrete GPU to do the image decoding, execute the inference. You could use the multiple hardware accelerators available in the Intel platforms in this case. It is so convenient. It is so easy to generate the video analytics pipeline, given and with the limited with the set of models supported by DL Streamer. And awesome open, it contains a curated list of projects. It could be of interest actually. And Intel also offers the edge computing educator program. This contains several courses for you to ramp up on the journey towards edge AI deployment. It includes the courses, short video tutorials on Intel distribution of open toolkit and open model zoo. It introduces to the open Jupyter notebook, open notebooks and others, and the student projects also. You can also get some more ideas on how to make use of open toolkit for your students thesis projects. And we have something called One API academic program, and One API is a different tool that contains a set of frameworks that helps you to optimize the end-to-end performance of the video or any kind of AI workload, whether it not only the video analytics. For example, let's say if you're training, you have a model trained using scikit-learn, you could make use of the Intel optimized version of scikit-learn to accelerate the performance of, let's say, for example, extremely gradient boost algorithm or any kind of decision trees. So it is a comprehensive toolkit that supports many other toolkits. Let's see, if you want to optimize the performance of OpenCV operations, then you could refer to the integrated performance primitives that is part of One API toolkit. You could make use of this toolkit if you would like to optimize the end-to-end performance of your workloads, not just model optimization. Besides model optimization, there are several modules that you need to optimize it to further improve the performance. And AI software portfolio. Please note that all these resources are available for free, and you could make use of this. This contains actually a list of short tutorials on generative AI, machine learning, deep learning, machine learning algorithms. If you are completely new to AI, definitely you could, I highly recommend this portal to get you started with the overview of different machine learning, deep learning algorithms available here. And PyTorch, TensorFlow, these are the scikit-learn gradient. So please refer to this portal if you'd like to, if you're very new to new to artificial intelligence and would like to wrap up on the algorithms and basics. training resources and certifications. Once again, here I would like to, if you would like to deep dive into OpenVINO Toolkit, I highly recommend this certification to you. And this is called Intel Edge AI certification program. You'll be visiting the, you'll have a deep dive into the different components of OpenVINO Toolkit with hands-on projects, and also that help you to deep dive into the different components of the what are the challenges in real-time projects, and how you could make use of the open model zoo repository or the open notebooks to accelerate your development time, and you'll get a set badge or certificate actually that could you would like to display it in on your LinkedIn profile or resume. I think it is offered. There's a free certification program. So if you'd like to deep dive into the open components or Edge AI deployment, refer to this certification. We also have MLOps certified professional course. If you like to know more, if you like to know, get yourself familiar with those methods that are after the deployment, post deployment methods like retraining, continuous CACD techniques, or how to retrain the model, continuous monitoring of the performance. Please refer to the Intel certificate, MLOps certificate professional certification. And they got in the generative AI use cases. So generative AI helps to make use of the complex deep neural networks, and also it helps you to generate the human-like response. For example, use cases such as video generation, text to image chatbots in case of languages, NLP areas, actually text classification, code generation, code llama and code instruction following chatbots are available. Music generation, text to audio, audio to text. These are the several use cases, and these are the models, corresponding models supported by OpenVINO Toolkit. And all the corresponding references, demos are available in OpenVINO notebooks. And we also have a dedicated repository called OpenVINO GenAI. Here we have the sufficient set of models and optimization techniques and demos based on the optimized models. Besides OpenVINO Toolkit, we also have something called IPEX LLM. IPEX LLM is a PyTorch library for running LLMs on Intel CPU or GPU with very low latency. And if you would like to integrate it with VLLM, it's very useful to, basically VLLM helps you to distribute the model. Let's say if you have a server and you want to distribute the model to multiple edge devices, you need to make use of VLLM to scale up the performance of the AI workload. And neural speed, the neural speed actually supports the efficient inference of LLMs on Intel platforms through the state-of-the-art low-bit quantization powered by neural compressor. Neural compressor supports a wide range of quantization techniques that further help you to accelerate the performance. So these two options could be considered if you would like to run the LLMs. And Intel extension for PyTorch compared to the native version, this helps to achieve the if you'd like to improve the training performance, you could make use of this Intel extension for PyTorch and transformers. And as mentioned, one API-based toolkit is a comprehensive toolkit that contains many more toolkits that help you to optimize the end-to-end performance of your workloads. Any questions? Any questions? Yeah, I will share the slide after the presentation in the PDF form. So next comes now let's go to the deep dive into the hands-on sessions that helps you to understand how to, basically the objectives of these hands-on sessions is to make yourself familiar in using the model conversion API, how to use the OpenVINO runtime API to deploy the model into your application, main application. Yeah. I'll demonstrate 4 different demos: image classification, and detection, segmentation, and LLM. Let's start with image classification. Before that, I will. This presentation slides actually contain the sufficient references to reproduce the demos and also installation steps as well. Anyway, I executed the demos on two machines. One is based on this demo is based on executed on 10th generation Intel processor. So why I'm mentioning is that this demo, the first three demos, object detection, classification, and instance segmentation, doesn't require any complex hardware or specifications. You can, if you have your laptop, it is sufficient. That is the beauty of this OpenVINO toolkit. It facilitates the deployment of AI workloads on resource constrained devices, or doesn't require without requiring any special hardware complexities. And so I have used Windows command prompt. I created a Python virtual environment, and don't worry, I have placed the sufficient references to the OpenVINO notebook. If you would like to know the installation steps, please refer to the OpenVINO notebooks please refer to the OpenVINO notebooks here. So here, this contains the sufficient installation steps to install the required dependencies of OpenVINO on Windows or Ubuntu or macOS. Yeah. So for this case, actually, I have used this. I have used the Windows actually. So you should be able to get this link. So for installation, please refer to OpenVINO notebooks link. Yeah, the first demo is image classification. In this classification, in this demo, I would like to show how to make use of the open model zoo tools to convert the model TensorFlow model into intermediate representation format, and how to make use of the OpenVINO runtime API to execute the inference. So first, I'm activating the virtual environment. I have installed OpenVINO development tool 2024.1 here. It's quite straightforward. Pip install OpenVINO dev. Sufficient to install the OpenVINO. If you'd like to install other dependencies, you need to mention the other dependencies like PyTorch or TensorFlow 2 along with the OpenVINO dev. So I'm using the notebook called Hello World. This notebook is also available on OpenVINO notebooks. But however, I have just fine-tuned this. I customized this notebook according to my requirements, so that I can provide a step-by-step guide for model conversion and optimization, model conversion and deployment. Hope you are able to see the video demo. So in this demo, I will show you how to make use of the open model zoo converter to download and convert the model, and how to execute inference with the OpenVINO runtime API. So since I have already installed the requirements, I'm just skipping this step. So here I'm downloading the notebook-utils.py that is required to download or other functions required in this notebook. So it is already downloaded here. You can see notebook utils. And here I'm downloading the model. So ResNet 50TF. I would like to download this model. So I'm using the tool called OMZ downloader, Open Model Zoo downloader. Just need to mention the name of the model and output directory, model directory. Please stop me if you have any questions. I hope this demo helps you to quickly develop or run the existing demos in OpenVINO notebooks or Open Model Zoo. So here the next step is, after downloading, we need to convert the model into intermediate representation format. So we are using here I'm using Open Model Zoo converter to convert this model that is available in PB. PB is protobuf binary. So this model was trained on TensorFlow. So by using this command, the protobuf binary format is converted into intermediate representation format. So you can see the successful outcome output of the model conversion. So here you're seeing two files over here. One is the .bin. These two files are saved actually after the successful model conversion. .bin contains the optimized model weights, and .xml contains the model topology. It defines where you can see the model input shape, the channel layout, or others, the model configuration topology. So here we're creating an object called core, opening a core object. This is the first step before executing inference. We need this opening a core object for the rest to load the model or execute inference or post processing the inference results. So here we need to mention the just a normal steps to we need to define the model path. The models are already converted and we saved in the FP16 directory. So we need to create the opening of core object. Then by using read model, we can read the model, load the model to the and it is optional. Sometimes if you don't have to make any changes to the model, you can directly use core.compile model. This step is optional. In case if you'd like to make changes in the optimized model, let's say if you'd like to reshape the model input, or change the layout, you need to read the model and do the changes and compile the model. Once you compile, we cannot make any changes to the model. So core.compile model, here also you can directly mention the path to the model XML file. Here this is the option to mention the device name, whether it is CPU or GPU or neural processing unit in case of Intel Core Ultra processors. This step is to compile the model based on the underlying hardware. So here we selected the CPU as the hardware, as the target device for executing the inference. So output layer, here we are getting the name of the output layer, which will be used in the next section. And once we load the model and compile the model, the next step is to load the image. You need to make sure you are giving you reshape the model to the exact shape required by the model. So for this, you need to be familiar with the optimized model. So when you open the optimized model, you'll be able to view the model input shape. This step is important so that you may avoid the error in the coming stage. So here the model input shape is 1, 224, 224, 3. The format, the channel layout is NHWC. That means the first one is the batch size. So here we are using the batch size of 1. The second one is the height in pixels and weight in pixels, and 3 is the the number of channels, RGB. So we need to reshape the input image according to this shape. So here we are, as you mentioned, the input image could be of any shape. So we need to, first step is changing the color. As you know, OpenCV loads the image, extract the image only in BGR format. So however, the model requires RGB image in RGB format. So this step helps you to convert the color from BGR to RGB. Then using OpenCV resize, we resize the image from to 224 by 224, and then we need to add one dimension because the model is expecting the batch size of 4 dimension. So we can add the additional dimension batch size like this actually. So now the input underscore image has 4 dimensions: batch size, height, batch is 1, and 224, 224, and 3 the channel order. So it is very important to know the model input shape before you do the pre-processing. And this step is where we are actually executing the inference. Compiled model, we already compiled the model as I shown before. So we need to input the image, the resized image that is expected by the model, and with the along with the output layer name, so that this step actually execute the inference on the compiled model with the for the given input image. The result underscore infer contains the probabilities or confidence levels of the different classes. So we need to find out the maximum probability. This way we are using np.orgmax. So this step actually helps to get the maximum the index that is having that with the maximum confidence or probability that will be used in the this index is used in the input ImageNet classes. Actually, this model was trained on ImageNet dataset, so we need to download the ImageNet classes file and just need to pass the index, this results index to the ImageNet classes to get the result. The objective of this demo is to predict the class of this input image. The input image is a pomegranate, so you need to make sure whether you are getting the image here, pomegranate. Feel free to stop me if you have questions, and if you have any questions, I request the moderator to let me know if you have any questions over here. Okay, now you have seen the demo for how to do the image classification. We have used open model zoo tools to convert the model, to download the model and convert the model, and we use the open runtime API to execute the inference, right? So now we are going to see how we can download the PyTorch model. We can, for example, let's say you have your own customized model and available in PyTorch framework, and this shows actually how to do the convert the PyTorch model using model conversion API and then execute inference using OpenNO runtime API. So this demo actually downloads the weights of ResNet 18 model, and this converts the context model.eval converts the context of the model from training to inference mode. And once again, once we, in both cases, whether it is PyTorch or OpenNO, once we load the model, we need to, for example, this script actually focuses on converting the model. As you can see, ov.convert model is used to convert the model from PyTorch into IR. So input, here we have mentioned the input specifically just to make sure that the resulting model has the predefined input shape. Otherwise, the batch size may be of undefined dimension. So since we are very clear about the input shape, here we are defining the input shape. The resulting model has the input shape of 1, 3, 224, 224. And also, interesting part is pre-processor. When you optimize the model using convert model, it is also possible to embed the pre-processing steps. Let's say some models require the input image to require some pre-processing steps like demean, subtracting the mean, or normalizing the image by certain values. So you can embed the pre-processing steps into the model itself, so that you don't have to define it for every image when you deploy it, when you execute the inference. It will be covered by these pre-processing operations are covered by the model itself, optimized model itself. So once we convert the model and embed the pre-processing steps into the model, we can save the model using this step, ov.save model. OV stands for OpenWindow, where previously we mentioned import OpenWindow as OV. So now the model is ready. So you should be able to view the optimized model files here. The open OV format is the directory name. So here you can see the optimized model files available in .bin and .xml. As mentioned before, .bin contains the model weights and .xml contains the model topology. And this just to make sure the input shape, what is the input shape and output layer shape. This step, now we have downloaded the ResNet 18 model and converted the model into IR format using OpenNO model conversion API. Now let's see how we could execute inference using PyTorch. This is the raw model, PyTorch model. Inference, loading the model and then pre-processing it, Pre-processing is available in the weight store transforms. So I'm making use of this technique to do the pre-processing. Then we are adding the dimension, one more dimension for the batch size. So the post-processing is same for the between the two methods, whether using OpenInno or PyTorch, because the post-processing here is just need to extract the maximum value and input that and use this as an index to the ImageNet classes file. As you can see, it is running actually the model, the PyTorch. Now the inference is being executed using PyTorch model. So here you can see the kernel is busy. So the input image is goldfish. So the predicted class is goldfish. This is the expected result. Now I'm showing you how to use OpenInno runtime API to execute the inference with the compiled optimized model. We recently optimized the ResNet 18 model. The steps are same as before. Creating the core object, loading the model, compiling it, and get the output layer name. Do the pre-processing. Pre-processing is an important step that helps you to avoid the errors related to the model shape or channel layout. Otherwise, you may get incorrect inference results, even if the channel layout does not match with the expected one. So here we are, doing the inference. We are sending we inputting the input image to the compiled model, and also along with the output layer. This gives the probabilities, get the maximum probability, and you can able to view the predicted class. Now you're seeing the goldfish over here. So the predicted class is goldfish. That is the expected result. Now I would like to show you, this is the most interesting part of this session, of this demo. This shows you how to demonstrate the performance improvement between the PyTorch and OpenInno. Using time-it module, I'm trying to evaluate the inference time with the PyTorch model. It is the model before optimization. So the time it is running, it actually evaluates the model. It runs the model across different iterations. Now you're getting 133 millisecond. This is the mean value. Executed 7 runs, and each run executed having 10 loops over here. Now let's evaluate the inference time of OpenInno model. OpenInno model means we are using the compiled model that we already compiled over here. The step we are executing the step corresponding to the inference execution. And now it's very clear we are getting 64.6 millisecond versus 133 millisecond, almost greater than 50% reduction in inference time. So this is the advantage of using OpenInno model. How we demonstrated how we could reduce the inference time with the optimized model, compared to the PyTorch format. So let me know if you have any doubts. Any questions? Any questions from the participants? If not, feel free to share your doubts or clarify questions so that I can clarify right away. Any questions from the participants? Hope you now understand how to make use of model conversion API and OpenInno runtime API, and also I hope you got the motivation towards using OpenInno to improve the performance. Now let's see the object detection demo. The same virtual environment. Now the different notebook actually. This is called YOLO V8 object detection notebook. So here I would like to demonstrate how to optimize the YOLO V8 model, YOLO V8N model, and execute the inference using OpenInno. The interesting part is YOLO V8 Alternatics repository itself provides support to supports OpenInno as a backend. So the steps are quite easy compared to the previous one, with minimal codes to execute the inference. And so the model conversion is different. I will show you how to, because the Ultralytics YOLO V8 repository itself supports OpenInno conversion to OpenInno and executes inference to optimized model. So after installing the required dependencies, OpenVINO, Torch, and other dependencies. Downloads the notebook utils file. This is required to execute some of the options like functions like displaying the image or downloading the files. So next we are downloading the Cocoa image, the input image to be tested. This is a typical image from the Cocoa dataset. YOLO V8 model is trained on Cocoa dataset, so I'm using the test input image from Cocoa dataset. So creating the models directory. Okay, here we are using YOLO V8. This is a typical. This code actually is available on YOLO V8 Ultralytics, and we're using the code. So here what we are doing is we are creating the YOLO object, instantiating the model from using a YOLO function, and creating the YOLO object, and get the model names that could be later used for displaying the inference results. And we have something called here. This is the step to execute the inference with the detection model. So we need to supply input the image over here. Image is the Cocoa, the dog image. So this step, image.from array is used to display the inference results. So RES contains the inference results. So now the inference is being executed on the CPU. Please note that here we're using .pt, PyTorch model. So this shows how to execute inference with the PyTorch model. So as noted here, it takes 557.1 millisecond for inferencing. So you can see the detection results over here. Car and dog, bicycle, different objects classes were detected successfully. Now let's convert the model to OpenVINO here. Previously, in the previous demo, image classification demo, we have used Open Model Zoo converter tool and then model conversion API from OpenVINO toolkit. Now, since Ultralytics YOLO V8 repository supports OpenVINO format, it's possible to use the export function and just change the format to OpenVINO to convert the model. And dynamic means actually if you want to keep the dynamic shape or not. If you want to keep static shape, like fixed shape 1, 3, 640, 640, something like this, then you need to put a false actually. If you keep this as true, the model accepts input of any dimensions undefined, and half equal to true because we are going to use the precision FP16, not FP32, FP16. So here the YOLO we open in a folder is created. You could see the optimist models .bin and .xml. And now let's see how to make use of the optimist model using OpenVINO runtime to verify the detection results. So as usual, create the core object, read the model, and compile the model, mention the device name, and here we create a function actually infer. So infer. So here infer. Usually this detect model actually has the infer method where we are changing the inference methodology from the usual PyTorch method to OpenVINO. That's why the model.pt is set as false, because here we are going to use the optimist model instead of the PyTorch model. So here we are calling the infer function. Sorry, we are setting the infer method to OpenVINO compile model. Now you could see the inference time over here, 169.3 millisecond. I think it's greater than inference time is reduced from greater than 500 millisecond to less than 200 millisecond. So you could see the significant improvement in the inference time. Inference time is reduced from 557 millisecond with the PyTorch model to 167 millisecond with the optimist model. So this is how this is also another sample to understand the performance, to witness the performance improvement with the optimist model. The use case is different over here. So next one is instance segmentation. The difference between the instance segmentation classifies the detection with pixel by pixel classification. It's so accurate on instance segmentation using OpenVINO. Let me share this demo in a full screen mode so that it is visible. There's the instance segmentation demo. Yeah. So open your notebook, but the notebook file is YOLO V8 instance segmentation. So once you activate the virtual environment, you're able to run the instance segmentation notebook. Yeah. So it's again after installing the dependencies, you can download the notebook utils. This will we'll explore how to load the model in PyTorch, convert the model, and validate the converted model in this instance segmentation demo using YOLO V8 seg. In case here you could see the NNCF neural network compression framework. As mentioned in my presentation, the previous slides, if you would like to quantize the model from 14.2, in this case SP16 into integer 8, you could make use of this NNCF tool. And if you're interested, you could refer to this notebook. This could further increase the throughput or latency, improve the latency of the model. And we move down and we decrease the precision from 14.2 integer 8. Install the dependencies, import the notebook utils that is required for the other functions, and then download the test image, CocoaBike. So now you're creating the directory, the previous one, same as before in the object section. So here we are mentioning, here we are selecting the model YOLO V8 seg. Steps are same. Create the object, YOLO object, get the label names, and execute the inference using this step. The results are stored in RES REST variable. So inference is being executed on CPU. So now we are executing inference in the instance segmentation using the instance segmentation model available in PyTorch format, pyt.pt. So 565 millisecond for inferencing. Let's see the detection results. Yeah. Now let's export the model to OpenVINO. Same. Here I mentioned dynamic true, so that means the input shape could be of anything like undefined. Half true, that means we are using, we are expecting the model with 14.16 precision. Select the device create the core object, read the model, compile the model. Yeah, model path. Hope now you're familiar with the steps of involved in running the OpenVINO API, loading the model, reading the model, compiling the model, then pre-processing the image. In this case, actually, the YOLO V8 repository takes care of everything and hides the complexity in extra code in pre-processing. And you could see now here, set compile tool model is infer function. We have defined an infer function that calls the OpenVINO model instead of the PyTorch model. And here you can compare the inference time 565 versus 369 millisecond. This is another example to understand to witness the performance improvement, and of course the results are good. So now let's move to the generative AI use case, LLM chatbot. This demo actually contains two use cases. One is with RAG and another is without RAG. So that I just made this tutorial, this demo, to understand the impact of RAG on the performance of LLM, on the real-time performance of LLM. This RAG stands for Retrieval Augmented Generation. Retrieval Augmented Generation. So augmenting means we are expanding the knowledge of the LLM. Usually, LLM chatbots are pre-trained on a large database, but up to a certain cutoff time, it may not be updated. It is not updated with the latest, the current knowledge or after the cutoff date. So if you would like to improve the performance of the LLM chatbot with the current knowledge, you could use retrieval augmented generation. So it augments the knowledge and it retrieves the relevant context from the latest document or from the latest database and generates the human-like response. So retrieval augmented generation. So expands the knowledge base, retrieves the closest relevant document and generates the accurate response. This demo actually makes use of OpenVINO as well as LangChain. LangChain is a framework that is used to accelerate the development of LLM chatbots, LLM-based use cases. For example, it contains several components like LangChain core. It includes the expression language. It is the building block for implementing the LLM components, and LangChain community, Langsmith is used to monitor the performance of LLMs. LangServe, something similar to model serving, it helps you to deploy the model in a distributed environment. So LangChain includes the components required for implementing the RAG. As you can see, this is the overall overview of RAG actually. First, we will see the LLM chatbot without RAG, and then we will see how to improve the performance using RAG. This steps 1 to 7. Steps 1 to 7 is offline. It is basically uploading the document, uploading the latest document, and tokenize it, and split it, and create the use the embedding model to create the vector. The role of embedding in LLM is very important because that is very important to convert the text into vector, and that is later stored in the vector store. Once the user gives the query, there is converted to the embedding model converts that into a query vector, and then in case of RAG, the query vector is combined with the latest knowledge. The vector store, I mean the latest document base, and then it generates the responses. And the re-rank actually ranks finds out the top most relevant responses, and it is then further used to create a new prompt, and that is used to the LLM to generate the response. So this helps you to improve the accuracy of the LLM or knowledge base of the LLM. So first one is activating the virtual environment. There are two notebooks. I have used two notebooks over here. Here, one is the LLM chatbot, another one is LLM RAG. I have also included the links in the presentation. to these notebooks. And I have used Llama 3 8B model, Llama 3 8B instruct model in the demo. So this demo covers how to, this is basically without drag. This demo is without drag. I have how to optimize the model, how to load the model. I mean, what are the different components of chatbot, like embedding model, 3 deep learning models are involved in the implementation of chatbot, embedding model, re-rank, and the LLM. LLM model that we are using, going to use is Llama 3 8B instruct. And what are the tools used to optimize the quantize the model? Because LLMs occupy more memory, so we cannot use the model directly. So we need to quantize the model from floating point into integer 4. So integer 4 precision is supported on OpenVINO. That helps you. This integer 4 precision facilitates the deployment of LLMs on edge devices. The only requirement is, even though you don't have to, you still don't have no need to have a, there is no need to have a discrete GPU, but you need to have a RAM size of 32 GB or 64 GB to quantize the model. Otherwise, you can use any server or any computationally expensive hardware to quantize the model, and you can deploy the model on the edge device on your normal typical laptop. So neural network compression framework is used actually to quantize the model. Here, it supports PyTorch, TensorFlow, ONNX, and OpenVINO frameworks. So let's see how we can use, how we can download the models, select the models. And so first step, and installing the OpenVINO Dev, Intel transformers module. GRadio is used to actually implement the interface, overall web interface, including the web interface to run the chatbot. PyTorch. After installing the dependencies, we need to download a config file. Actually, this config file is available in the OpenVINO notebooks. It is just copying the notebook, this file from another directory to here actually. If you want to run this demo, you need to sign in. You need to have a valid account on Hugging Face, and you should be able to get the permission to download the model. So it's open source, but still you need to make use of your account to download the to access the Llama 3 model. So here we are selecting the model language, English or English. So model, next step is selecting the model. So we are selecting Llama 3 8B instruct. Let's confirm the selected model from the widgets. So optimum CLI is the command line utility. It is part of Optimum Intel, and that helps you to optimize the model, quantize the model from FP32 to integer 8. It also converts and also do the quantization. For example, if you did not mention it, it converts into FP16. If you mention the integer 4 quantized compression weight format, yeah, here you should be able to see the parameters. For Llama 3 8B here, the parameter symmetrical quantization and group size and ratio, the standard parameters used in quantization. Yeah. So this is the overall command actually used in the quantization. As you can see, the format is OpenVINO model. We are giving the model name, actually model ID on Hugging Face, and the task is text generation. And the weight format here, we need to mention the precision, whether it is integer 8 or 4. Here we are using integer 4 and the output directory. And the type of quantization is symmetrical quantization. This way we are using SIM here, SYM. Once you quantize the model is reduced to only 5 GB. The optimized model, the size of the optimized model is only 5 GB. So other variables, just set the model path. You're getting the error because FP60. Here I'm not using FP60, so just ignore the error. Now let's see how to use OpenVINO to execute the inference. And once again, this demo is executed on Intel Core Ultra processor. This comes with the Intel Arc GPU. The only thing is this machine has 64 GB RAM and 1 TB hard disk. I think 32 to 64 GB is the main requirement for quantizing the model. If you just want to deploy the quantized model, I think that's fine. You can still use your laptop with the standard conventional specifications. So here we are using the OV model for casual LM to execute the inference. Here we mentioned the device name, model directory. Model directory refers to the quantized integer 4 model. So compiling the device to GPU. So in this way, now we have what we have done is we have quantized the model. We have converted the model into intermediate representation format, and also we changed the precision from 14.16 to integer 4. And now we are trying to execute the inference using OpenVINO runtime. Other standard parameters of the LLM, like temperature, that determines the level of creativity, and can fine tune it. So, okay. So the difference between the conventional chatbot or instruction following chatbot and this one, smart chat, intelligent chatbot, is here actually we are using here in when we have the query from the user query. Along with the user query, we need to add the previous conversation history so that the model is able to understand, is able to generate the relevant response. Okay. So along with the user input query, this is overall architecture of chatbot actually. So along with the user input, the previous conversation history has to be added and then tokenized it, and the token IDs are generated input to the LLM, and LLM generate the probabilities in the format of logits, and it estimates the next token. And so by using the tokenizer, then the token IDs are converted back to the text, actually generated text, predicted text from the model. And here the thing to be noted here we have used GRadio to implement the chatbot interface. And this is the code. This code is also included in this notebook. And once you execute the GRadio, okay, now I would like to demonstrate the performance. Let's see. Actually, OpenVINO has been introduced before 5 years. This is the latest model. So when I ask the question, what is OpenVINO, I'm getting the response. Okay. So the chatbot is available on this interface and this local server. So here, okay, let's just first is the generic performance of the LLM. This is the latest model, and so let's see what is the response to the what is OpenVINO. The response that is being generated is quite relevant. Recently, Intel launches the Intel Core Ultra processors in last December. So this model may not be trained on the data, specific data. So let's check whether let's test the performance in response to the latest question. Let's say something else related to the Intel Core Ultra processor. vPro technology is already available, but it may not be aware of Intel Core Ultra processors. Sometimes the response may be hallucinating. The model LLM may be hallucinating. That means it uses, it just generates the generalized response, but it may not be so specific to the question we asked. So here actually, it did not mention anything about the Intel Core Ultra processor. Core processors are different from this Core Ultra processor. So I think there is a difference between the this shows that we cannot use this LLM chatbot for the latest information. So it's me. Let's in the next one actually we'll see how we can improve the performance of this LLM using retrieval augmented generation. If you ask any questions relevant to Intel Core Ultra processor, it is hallucinating. The response is not accurate. So let's see now how we are make use of retrieval augmented generation. So in retrieval augmented generation, we already do in the offline. We already load the document. We update the vector database with the latest document that we want to update the LLM that we want LLM to be aware of. The initial steps are same, but here we have three models. One is besides the LLM Llama 3 model, we also need to use embedding model and a re-rank model. Embedding model is used to generate the vector. Sorry, in both cases we used embedding model as well as the re-rank and LLM. But here the difference is there is a RAG pipeline that comes into picture. So re-rank. So re-rank and embedding of the exclusive modules in RAG. Let's see here as is shown here. This is the offline step. So if you want to load any document, you can load the document, split it into chunks, and use the embedding model to create a vector, and then you save it in the vector database. This is the offline process. Then we can create the RAG actually. RAG involves re-ranking the model as well to generate the topmost relevant responses. Let's see how we can see. Actually, there's a sample file called the text example. Maybe I could open it. Yeah, this contains this. If this document contains the information about Intel Core Ultra processor, what are the different accelerators, does it support vPro or not? This is something specific information that is not LLMs are not aware of it. Now let's load this document. Let's load this document and build the vector store. Update the vector store with this document. Now the database is ready with this updated information. So if you want, you can change the default parameters of the LLM, like temperature, the level of innovation, and other stuffs. Now let's ask something specific to the document we uploaded. Let's see whether the LLM could answer this question relevant to the Intel Core Ultra processor. Previously, without RAG, we don't have this feature to add the latest information. Now it's possible to update the database with the latest data. Yes, so this is the specific details of the Intel Core Ultra processor, and I also provide some additional information like this that is relevant to the vPro. And these are some other questions that are specific to the document that we uploaded. So in this way, now we could be able to improve the accuracy of the LLM by uploading by augmenting the existing knowledge base. So now it is able to retrieve the best or most relevant response and generate the human-like response with more accuracy. These are some questions relevant to the this specific document, text example en.pdf. So basically, with proof, it just does not it is not hallucinating because the response is so specific, and also with the reference to this document. So in this way, if you'd like to explore more on this one, please refer to the Open notebooks. It also contains more generative AI use cases like text to image, content generation, and use cases as well as others. And we have been the new set of LLMs are being added to the OpenVINO notebook, and yeah. For example, it also contains multimodal LLM use cases like video understanding. For example, you could upload the image and get the response. You can ask questions relevant to the image, and you can ask the chatbot to summarize the content in the image or video, in case of multimodal LLM. So that's all about my presentation today. So let me know if you have any questions on the tutorials or theoretical aspects of OpenVINO, how to access the tutorials. I already mentioned that you could refer to OpenVINO notebooks, and I will share the PDF version of this presentation slides for you. I highly recommend you to have a look at the existing learning resources to get you started to ramp up on your AI journey. And good luck to you. If you have any questions, let me know. Any questions over here? Let me know if you have any questions. I will share the PDF version. Hi, Imran.
No. There is no question from the comment section.
Okay.
Just
Great.
okay. Yeah, there is a question from Hattori. It says, Doctor.
Can I use the integration of Llama and OpenVINO for other languages such as Malayalam? Yes, you can. You can fine tune it. Now, actually, for example, in Malay language, actually, this is one of the trending use cases. In India, I think they have developed the chatbot for different regional languages. Yes, it is possible. It's possible to fine tune it. Actually, there is a difference between fine tuning and RAG. For example, cases like this, you are entirely changing the language itself, right? So I think in this case, you need to fine tune the model. You can download the pre-trained model that is trained on English, and you can, but it requires a lot of computational resources. However, in case of RAG, if you still want to, if you don't have to change the language, but you want to update the knowledge base, you can use RAG. Otherwise, for changing the behavior of the LLM, you need to fine tune the model. In computation, normally there are two techniques like transfer learning and fine tuning. In transfer learning, we just download the pre-trained model such as YOLO V8 or YOLO V7, the existing model trained on the large data set, and then you just use it. If required, you can, if your data set may contain different objects or size something that is different from the original data set, you may need to fine tune just need to train the last few layers of the model. Similarly, here also we have whether you need to decide between RAG as well as fine tuning. RAG versus fine tuning. Yeah. Any other questions? Thank you. Thank you, Hattori. So let me know if you have any questions offline. Yeah, I'm ready to answer, help you in your AI use cases. Yeah. Over to you, Imran.
Okay, I will leave about 1 minute for the audience to ask any question, and if there's no question, we may proceed.
So I will email the PDF version of my presentation slides to the organizing team. Yeah. Is this fine?
Yeah. Is this the end of the program, sir?
Yeah, I can email the PDF version of the presentation slides to Professor Sakina or Dr. Intan.
Okay, I think that's all the time we have left. First of all, I would like to thank you, Dr. Ramesh Perumal, for the great sharing and teaching us. Now, before we end this event, I would like to remind participants to sign the register form and give us a little feedback on how do you think about this program. My team will provide the register and the feedback link for you in the comment section. Now, any students that watch this from UTEM, as usual, there will be a special QR code just for you. The QR code is for your SMP marks and it may help with your future. I will give the audience around 1 minute to fill in those forms. Thank you. All right. Now it is around 3:52 in the evening. It is quite sad that we reached at the end of the program. So we like to express our sincere gratitude to Dr. Ramesh for sharing his valuable expertise. A big thank you for the audience for giving us the time to join us today. We hope that this web webinar spark meaningful discussions and ignite your interest in the future of AI. We look forward to seeing you at the upcoming Y Summit 2.0 at UTEM 2024. Once again, goodbye and thank you for being part of our journey.